Hello, welcome to Advanced Composites. Today is the 5th day of the ongoing class in the 8th week of the course, and yesterday we developed the governing differential equation for a plate which is symmetrically laminated, and also it is especially orthotropic in nature. So, because it is in having such a lamination sequence, its out of plane and in plane solutions get decoupled, and the governing differential equation assumes the form as shown here. So, this is the governing differential equation for variable w, which is out of plane deflection. So, now what we will try to do is we will try to solve this equation in the context of the problem described, that is, the plate is having simple supports on all the 4 edges and also it is uniformly loaded in the transverse direction. So, the first step is we guess W naught x y, we guess W naught x y. So, our guess is that, so we guess a series solution. So, this is equal to W mn, which is a constant, times sine m pi x over a sine n pi y over b. The reason we are guessing it in such a way is, so W mn is a constant that if nothing else, this function will satisfy the condition on W, which is that W is 0 at both the edges, on all the 4 edges, and this is a summation on both the terms m. So, m can be from 1 to m and n can be from 1 to n, okay. And this capital N, and or we can make it an infinite, it could be anything, it could be an infinite series. So, second, verify if BCs are satisfied. So, the first BC is W naught x y equals 0 on all edges, okay. So, what are the edges? X is equal to 0 or a. So, when we look at the problem definition, x is equal to 0 on this edge and x is equal to a on this edge. Similarly, y is equal to 0 on this edge and y is equal to b on this edge. So, these are the 4 edges, y is equal to 0 and b. So, when we plug in x is equal to 0 in this equation, w becomes 0, and when we plug in y is equal to 0, so this solution, the boundary condition on x is equal to 0 edge is satisfied. Similarly, when we plug in y is equal to 0 in this equation, it gets satisfied. So, boundary condition on y is also satisfied. Similarly, x is equal to a, when we put it in here, then it is equal to m pi sine of m pi, and sine of m pi is again 0. So, boundary condition is satisfied on both the x edges and similarly on both the y edges. So, at least from the standpoint of boundary condition on w, this function satisfies our requirement. The second is mx is equal to 0 on x is equal to 0 and a. Now, what is mx? Mx is equal to d11 del 2w over del x square minus d12 del 2w over del y square minus d16 del 2w over del x del y, but d16 is 0 because of lamination sequence. So, it is d11 second derivative of w in x plus d12 second derivative of w in y. Now, let us see whether these two boundary conditions are satisfied. So, when I differentiate this function of w with respect to x twice, I again get the sine term, and that sine term will still be 0 on x is equal to 0 and x is equal to a. So, this boundary condition is also satisfied, and the third boundary condition is my is equal to 0 on x on y is equal to 0 and b. So, what is the definition of my? My is equal to minus d12 del 2 w naught over del x square minus d22 del 2 w naught over del y square, and then my d26 term which is 0. And again, when we plug in the value of w from this form, we again see that it satisfies. So, these two boundary conditions are also satisfied. Actually, all the three boundary conditions are satisfied. All BCs are satisfied. So, our assumed function w, it satisfies all the BCs. So, the next thing is that it should also satisfy the governing differential equation. So, we check that. So, then the thing is check whether assumed solution satisfies PDE. Okay. So, when we plug in, so what we have to do is we are plugging in this equation. So, this is equation 1 and this is equation 2. So, we are plugging in this series solution for w in equation 1. So, what do we get? And so when we plug it in, what we get is, so I will write this equation once again. Okay. So, once I plug in the solution, I get a series term m is equal to 1 to infinity, n is equal to 1 to infinity, and in the brackets we get d11 m pi over a to the power of 4. See, when I plug in and I differentiate this term, this with respect to x 4 times, I will get m pi over a to the power of 4. So, I get this plus 2 d12 plus 2 d66 times m n pi square over a b. Okay, plus d22 n pi over b to the power of 4 multiplied by sin m pi x over a sin n pi y over b, and this equals q naught, and q naught is a constant. Q naught is a constant. What I will do is, this long expression I will call it dmn. just to make our life, I do not want to write these long things. So, I will just rewrite this equation very quickly again. dmn sin m pi x over a sin n pi y over b is equal to q naught. Now, if we can show that in some special condition this left side and right side are equal, then our assumed solution is correct. If we cannot show that these sides are equal, then we cannot claim. Oh, there is one thing I forgot to mention. There was a Wmn which I omitted. So, this entire thing is also multiplied by Wmn. This Wmn is not known, and if we can select some special values of Wmn such that this entire thing equals q naught, then we have solved the problem. So, let us call this equation 3. Now, q naught is a constant, and we know that we can express constants as Fourier series expansions. We can express constants as Fourier series expansions. So, what we will do is we will express this q naught in terms of a Fourier series expansion. Okay. But most of the times when we deal with Fourier series, we talk of only one dimension. So, we say that constant C1 is equal to sine of 2 pi x over a plus sine of 3 pi x over a, and so on and so forth, but here both dimensions are involved. So, this will be a 2-dimensional Fourier series. So, what we will do is we will do Fourier series representation of q naught. So, we will assume q naught, which is a constant, is equal to double sum of Qmn sin m pi x over a sin n pi y over b, and m is equal to 1 to infinity, n is equal to 1 to infinity. So, the larger the number of terms we take, the more accurate this q will become, and then these are unknowns. So, we have to calculate these unknowns. Okay. So, how do we calculate them? So, this is again standard Fourier procedure, just expanded to 2 dimensions. We multiply both sides of this equation by sin I pi x over a and sin j pi y over b, and we integrate this both sides over the domain of the problem. So, we do what we are doing is we are integrating after multiplying both sides by sin I pi x over a sin j pi y over b dx dy equals 0 to b, 0 to a, Qmn sin I pi x over a sin m pi x over a sin j pi y over b sin n pi y over b and integrated with respect to dx and dy. So, this is dx times dy. Okay. So, I cannot write the everything in that one line. So, it is dx times dy. So, this is how we compute these unknown constants qmn. Okay. So, the left side or the right side, so what we do is we use a result. So, we know, so we know that 0 to a, for instance, sine of I pi x over a, sine of m pi x over a dx. See, when we so this is equal to a over 2 if I equals m and it is equal to 0 if I is not equal to m. This is a standard trigonometric identity. And similarly, we know that for the y integral, so this is equal to b over 2 if j equals n and 0 if j is not equal to n. So, essentially what this means is that this entire integral I can express it as, and of course, this has to be summed up for all values of qmn, because this summation, we forgot to put this because we said that q naught is summation of this. So, this summation we omitted. Okay. So, what this means is that this entire integral gets simplified if I use this result. So, what it becomes is, so this becomes, so I will rewrite this integral 0 b 0 a q naught sine I pi x over a sine j pi y over b dx dy equals, and I and so the integral of sine I pi and sine m pi, that will be a over 2 only when I is equal to pi. So, I is equal to m, right, I is equal to m. So, essentially if I use this relation, I end up with q I j times a b over 4. Okay. q I j times a b over 4. And what do I get on the left side? On the left side, so this is equal to, so the left side becomes q naught. So, what is integral of 0 to a, let us say, sine I pi x over a times dx. So, it is equal to 0 to a, it will be equal to a over I pi, and there is a negative sign, cosine I pi x over a evaluated, I am sorry, there is a negative sign, evaluated between limits 0 and a. If x is odd, then this becomes, so this becomes I over I pi times two possible values. If x is even, if I am not saying, if I is even, then this becomes 0, and if I is odd, then it becomes minus 2. Cosine of, so we will consider, suppose I is 1, then it will be cosine of pi times a by a cancels out, right. So, cosine of pi is minus 1 and cosine of 0 is minus 1. cosine of 0 is 1. So, minus 1 minus 1 minus 1, right, minus 1 minus 1. So, it becomes minus 2, right. So, if so this is if I is even and this is if I is odd. Okay. So, we get basically q, and similarly we have similar integral for sin j pi y over b also. So, essentially we get q naught a by I times j times pi square b into 4 is equal to q I j, I am sorry, q I j times a b over 4, because minus 2 gets multiplied by minus 2, I still get positive 4. Okay. So, the value of q I j is equal to 16 q naught over I times j times pi square, or I can also say that q m n is equal to 16 q naught over pi square m n. Okay. So, this is equation 4, and I plug this equation 4 in equation 3. I plug this equation 4 in equation 3. So, I get, so if I combine from 3 and 4, what do we get? This is the thing we get. Okay. Now, this left side and right side will be equal, it will be equal only if this term is equal to this term, because other terms are same. So, if that is the case, then we can say that W m n is equal to 16 q naught over pi square m n times d m n. So, the solution for W, so now we have seen that this assumed solution satisfies all the boundary conditions and all the differential equation also. So, the solution for W is double summation 16 q naught over pi square m n d m n times sin m pi x over a sin n pi y over b. So, this is the solution for the out of plane problem for a simply supported plate, which is a laminated composite plate which is simply supported on all the 4 sides, and this plate is also not only symmetric in nature, but it is also especially orthotropic. So, for that kind of a plate, this is the solution for out of plane displacement, that is W. And the geometry of the plate, that is its dimensions A and B, they are embedded in 2 parts. They are embedded in here, they play a role, and they also have a role in definition of DMN. Okay. So, this is the solution, and what we will do tomorrow is we will continue this discussion on this simply supported plate on all the 4 sides, and then once we finish the discussion on this problem, then we will move on to some other problems. Okay. So, thank you and have a great day. Bye.